Welcome.
I'm doing my presentation today, so what time am I doing it?
You'll do your second.
After this one? All right, cool.
Yes, welcome. This is the IIBA Tampa Bay, Florida chapter study group. This is our 32nd consecutive class. Welcome to May of 2022. We have a mission to bridge the gap between industry leaders and business analysts by building partnerships with professionals, educators, and employers so that we may empower, instruct, and engage the Tampa Bay IT community. Now, if you've been with us before or not, let me let you know that we not only serve the Tampa Bay IT community, we also serve all of Northern Florida and anyone else in the entire world that wants to join us. As you can tell, we provide a considerable amount of education. We also provide networking, resume reviews, assistance in helping find jobs, all kinds of stuff. So if you'd like to join us, join the IIBA and you can join our chapter. We have a variety of ways you can access our information. You can see our past meeting recordings there, highlighted in turquoise. We have our BABOK study group every Tuesday from 7 to 8 Eastern. We have our meetups. We have the meetup group, and that has not only this class that is every week, but we also have a variety of other lunch and learns that are offered. There is a Zoom online way to access us. There's the IIBA site, website, meetup, Facebook, and 2 different LinkedIn groups. This is a list of the meetings that we had, numbers 2 through 17, and what we covered in the BABOK. You can see our scores weren't always stellar, but the conversation that we had during those meetings to help identify why this was the best answer or what we got wrong on this answer is really what gives you information about that particular thing. What we did in these is we went through the Watermark Learning's practice test questions. And as you know, those are multiple choice questions, but they are tricky because you have to pick the best answer according to the BABOK, which isn't always real life, but it is according to the BABOK. And so that's how you pass the test. Our organization is a volunteer-run organization led by our president, Cliff Gray. You can see him there in his Star Wars X-Wing something or other. And you can also see a picture of him here. Lori is our Vice President of Finance. Caitlin and Priscilla are board members at large. They lean in whenever we need assistance. My name is Thea Tanner Raisins, or Thea Raisins, depending on what I have written here. It's my full legal name. I'm the Vice President of Career and Professional Development. You can see my LinkedIn profile address here. If you want to contact me for mentoring or anything else, this is the way to do it because it gets lost in my email. We have had, as I said earlier, a whole bunch of classes. And, oh, I'm sorry. I got to go to slide number 7, which is the most important one. Bob Churchill is the one that makes this study group legit. He is the certified business analyst professional, the CBAP. He's passed the test. He has the letters after his name. And not only does he have those letters after his name, he has this plethora of other letters after his name that prove that he has all of these certifications and tests that he's passed. He is here with us today again, as he is always, but he also has this awesome website that has a really great variety of information that is quite, it exceeds the reach of most business analysts. Bob has a varied history that brings in information from project management, mechanical engineering, process analysis, and finance, of things that he knows that I will never be able to learn, but I'm going to try. At the end of the meeting, I will be updating this, which is our attendance sheet. Your hour here participating in this class allows you to have a credit of 1 hour of education credit, which is necessary whenever you're applying for your certification for any of the tests, as well as renewal. So this is what I've been keeping up with. As you can see, this is our 32nd class. We have a lot of people. We have a whole nother page of this. And Cliff is kind enough to do a screenshot of everyone who attends, and I go in later and make update. So what we're going to do now is I'm going to turn it over to Bob and ask him to do the, let's see. Bob today is going to do data mining, which is something that Cliff is going to be able to lean in on. Data mining is one of the topics in the techniques chapter. It's 10.14 in the BABOK, which is the Business Analysis Book of Knowledge. That is the book that you have to learn to be able to pass any of the certifications based on it. So I'll give it over to Bob now. And after he finishes with that, we have Ben that's going to do risk analysis and management. And then I will do metrics and key performance indicators, or KPIs. So take it away, Bob.
Okay, can you?
Okay, take yourself
Lost
off.
you, Bob.
Try it again, Bob.
You're still on mute, Bob.
Yeah, but he's freezing. Okay, why don't we let Ben go ahead and do his, and we'll let Bob come in after that.
Mine won't take that long. So
Okay, go ahead, Ben.
should probably take about 10 minutes. So I'll do mine quick. So I'll share my screen. And also, can I play a 5-minute video afterwards? Is it okay?
Yeah, we'll have time. 15 minutes isn't too long for
On
one.
YouTube, I found a really good clip on YouTube. Maybe I can share it. All right, sure. Thank you.
Okay, great. As long as it contributes to the understanding of the topic.
Exactly. Yeah, of course. It's not Tom and Jerry. Nobody has time for that. That's funny. I found that funny. All right. So my name is, those of you that know me, I'm pretty new to the group. My name is Ben Hur. I'm currently located in Alexandria, Virginia. I'm a recent graduate from George Mason University. I graduated with a bachelor's in IT and a minor in business. I've been working in the IT field for the past 3 years. I've done IT support, help desk, tier 1, tier 2, a couple internships. So my background is all technology, but I have passion. I mean, it took me a while to find out what I really want to do, but I have passion for, to become a business analyst and pursue a career in business analyst and grow in that career field. And I'm very passionate about it because it leverages my strength and what I want to do. So that's why I'm involved in this group. I want to contribute. I want to grow and help others, and then also give back at the same time. So my topic for today was explain risk analysis and management with BABOK with examples. So I put together definitions of risk analysis and management and with examples with my own understanding and research. So let's get started. Description. So what is risk management? Risk management is an ongoing activity, continuous consultation and communication with stakeholders that helps both identify new risks and to monitor identified risks. Risk analysis and management involves identifying, analysis, and evaluation risks. And what is the purpose? The purpose of risk analysis and management, it identifies areas of uncertainty that could negatively affect value, analysis, and evaluates those uncertainties, and develops and manages ways of dealing with risks. Can be applied to strategic risks, which affects long-term values of the enterprise, tactical risks, which affects the value of change, and operational risk, which affects the value of a solution once the change is made. An organization typically face similar challenges on many of its initiatives. So it depends. It varies. Risk analysis and management is, it varies from company to company, situation to situation, and it can be applied differently. So what are the elements of risk management analysis, right? Risk identification is one, risk analysis second, and then third is risk evaluation, and then risk treatment. These are the main elements I'm going to discuss, right? So risk analysis management. These are just put together examples of risk management. this is the cycle. It assesses, it evaluates, it manages, and measures. It's just a visual representation of risk management. It monitors, it identifies, it treats, and evaluates. So these are just visual identifications of risk management. And I have another visual representation of with the examples. This is the complete breakdown of risk management. One is it initiates, right? And then identifies, it assess, plan responses, and implements responses. And you are able to manage this process. This is a visual representation of risk management. A picture says 1,000 words. All right. Oh, what am I doing? That the risk management example, right? So the next one is risk analysis. Risk analysis. These are the steps of risk analysis. These are the steps. Step one identifies the hazards, and then it goes around, knows the risk, and controls the risks of the situation, control situation, and controls the risks, and then reviews control measures. So this is a consultation of analysis, the visual image of the process. And the definition of risk analysis is it defines a sequence of process of risk management, planning, analysis, identification, and controlling the risk on a project. The risk is any uncertain events or condition that might affect the business analysis effort that impacts on the outcome of the business solution. And I have an example of risk identification. I found research I did. So there's a breakdown of risk identification, how risk is identified, brainstorm the causes checklist of each industry, how it does it differently, and like the root cause analysis, SWOT analysis, the interviews, documentation reviews, risk breakdown structure. I remember doing that in school. Influence diagrams, force analysis, field analysis, documentation reviews. It's going to be breakdown of risk identification. Example, what a risk identification, proposal looks like. Risk definition, risks are discovered and identified through a combination of expert judgment, stakeholders, input, experimentation, past experience, and historical analysis of similar initiatives and situations. The goal is to identify a comprehensive set of relevant risks and to minimize the unknown. Risk identification and ongoing activity. Risk control, right? What risk control does? It avoids, accepts, transfer, and reduce. Risk control includes identifying procedures for risk avoidance, loss control, risk transfer, strategies, and potential risk retention. Risk analysis. Analysis involves understanding risk estimates, the level of risk, the consequences of risk are described in terms of their impact or potential value. The impact of any risk can be described in terms of cost, duration, solution scope, and solution quality. And it's just having an evaluation, a risk process diagram, how the risk flow diagram looks like. You are able to identify the risk, and it's slow the image, but you can see it. Risk, assess the risks, develop assessment criteria, and assess the risks, and it goes in order with interactions, priorities, and response to risks. This is how a flow diagram looks like of risk assessment, assessing the risk. And the evaluation, the risk analysis results are compared with potential value of the change or the solution to determine if the level of risk is acceptable or not. An overall risk level may be determined by adding up all the individual risk levels. All right. And this is my last slide of risk treatments. Treatments of risks are one or more approaches to dealing with risk may be considered, or any combination of approaches could be used to address the risk. So the four main treatments are to avoid, to transfer, to mitigate, to accept, and to increase. So when you avoid, either a source of risk is removed or the plans are adjusted to ensure that the risk does not occur. To transfer, the liability for dealing with the risk is moved to or shared with a third party. To mitigate, to reduce the probability of the risk occurring or the possible negative consequence if the risk does occur. Accept decides not to do anything about the risks. If the risk does occur, a workaround will be developed at that time. To increase, it decides to take one or more risks to pursue an opportunity. So that's my presentation on risk management, risk analysis and management with examples from BABOK and IIBA. I hope you guys have a better understanding what risk analysis and management is, right? Hopefully it was helpful. I want to play one more quick video. It's only 5 minutes. I thought I found this very helpful. Something I found on YouTube. So I want to share.
This is Devashish.
Can you guys hear this?
We're going to talk about risk analysis and management.
You guys can hear this, right? You guys hear the sound? All right.
Yes.
Key technique of business analysis. Let's start with the basic concept of risk, or what is
Can you
risk.
share the screen? Or is
Risk
this,
is any uncertainty of an outcome.
Oh, sorry.
Now, failure to identify and manage risk.
I
Hello,
apologize.
everyone.
Can you guys see now? Can you
This
see
is
guys see the
Devashish,
screen?
and today we're going to talk about risk
Yes.
analysis and
Yeah.
management,
I forgot to share the
which
screen.
is a key technique of business analysis. Let's start with the basic concept of risk, or what is risk. Risk is any uncertainty of an outcome. Now, failure to identify and manage risk may negatively affect value of the solution. Where sufficient controls are not properly in place, business analysts develop plans for avoiding, reducing, or modifying the risk, and when necessary, implementing these plans. Risk management is an ongoing activity. Continuous consultation and communication with stakeholders helps to both identify new risk and to monitor identified risk. Risk analysis and management involves identifying, analyzing, and evaluating risk. Let's move ahead with the purpose of risk analysis and management. Risk analysis and management identifies areas of uncertainty that could negatively affect value, analyzes and evaluates those uncertainties, and develop and manages ways of dealing with these risks. Can be applied to strategic risk, which affect long-term value of the enterprise, tactical risk, which affect the value of a change, and operational risk, which affect the value of a solution once the change is made. An organization typically faces similar changes on many of its initiatives. So the purpose of risk analysis and management is to identify those changes and use the treatment again and again so that it becomes cost effective. Now, the risk analysis and management consists of 4 different elements. It starts with risk identification, then risk analysis, risk evaluation, and then risk treatment. We'll start with risk identification. A risk could be once occurrence, several occurrence, or even non-occurrence of the conditions. You cannot start working on a risk until you completely identify a risk. Now, risks are discovered and identified through a combination of expert judgment, stakeholder input, experimentation, past experiences, and historical analysis of similar initiatives and situations. The goal is to identify a comprehensive set of relevant risks and to minimize the unknowns. Risk identification is an ongoing activity. Moving ahead, you go to risk analysis. The likelihood of occurrence could be expressed either as a probability such as low, medium, or high. Analysis of risk involves understanding the risk and estimating the level of risk. Sometimes control may already be in place to deal with some risk, and these should be taken into account when you're analyzing the risk. When we move ahead, we go to risk evaluation. The risk analysis results are compared with the potential value of the change or of the solution to determine if the level of risk is acceptable or not. Some risk may be acceptable, but for the other risk, it may be necessary to take measure to reduce the risk. One or more approaches for dealing with the risk may be considered, and any combination of approaches would be useful to address the risk. There comes risk treatment in picture. There are 5 risk treatment here. Starts with risk avoidance, transfer the risk, mitigate the risk, accept the risk, or increase the risk. If I talk about avoid risk, either the source of risk is removed or the plans are adjusted to ensure that the risk does not occur. When I say transfer the risk, the liability for dealing with the risk is removed or shared with a third party. Mitigate the risk. Reduce the probability of the risk occurring or the possible negative consequences if the risk does occur. Then comes accept risk. Decide not to do anything about the risk. If the risk does occur, a workaround will be developed at that time. Then increase the risk. Decide to take on more risk to pursue an opportunity which is favorable to you. So these are the 5 risk treatment available, starting from avoid the risk, transfer the risk, mitigate the risk, accept the risk, and increase the risk. Which brings us the 4 elements of risk analysis and management, starting from risk identification, risk analysis, risk evaluation, and risk treatment. Thank you.
I think what really sets apart the latest release of Exposure IQ is the capability to identify accumulations of risk across.
So
That's it.
let's talk about risk for just a second.
Mhm.
They talked about different ways to deal with risk. I'd like to address that just a little bit. Risk avoidance is how do we keep something from happening? So let's talk about loss prevention in retail stores. How do you keep loss prevention? How do you keep loss prevention measures so that people don't take all your merchandise? Have you ever walked into a retail store and had a security guard say, welcome? Because they're right there. They want you to know they're right there. That's a risk, a loss prevention measure that they've done intentionally to try to mitigate the loss. I worked for a company one time that they realized that they were going to be fined if they didn't change one of their processes. They were going to be fined like $80,000. But if they changed their process, it was going to cost them like $500,000. So they accepted that risk. They just accepted the trade-off because it was worth it to them. So whenever you talk about risk, you also have to talk about what are the indicators that that risk is happening and build that in, especially if it's high to medium probability that that risk could happen. What would the indicators be? And if you do see those indicators, what steps need to be taken? Because whenever you are in that situation, sometimes you can't think, you panic. You don't want to have to try to figure it out whenever you're in the panic mode. Does anyone have any other points that they want to make about risk?
You could talk about all the old Ford executives that made that decision on the Ford Pinto.
True.
It was a very costly.
Yeah.
Risk analysis cost them dearly.
What was that car that they made that they said was put together with baling wire? I mean, it was just a really poorly designed car that fell apart, but they put it out on the market. Somebody didn't do.
Yeah. The Pinto was where they put the gas station or the gas tank in the back of the car with no protection.
Oh, good.
And yeah, they had a bunch of people die, of course, in accidents. And they thought the risk to redesigning the car versus paying out settlements was better. So.
And how'd that work out for them?
It didn't. It didn't.
Not well.
Let's put it this way: they look at the financial, but they didn't look at the perception, the news, and everything else. I mean,
yeah,
Ford took a huge hit because of that.
You know, the acronym.
Financially.
The acronym for Ford, found on the road dead, takes on a whole new light after that story.
That's also spoofed in the movie Top Secret, if you ever see that.
Okay.
Humor about 1983.
Okay, cool. Anybody else have anything else about risk? Ben-Hur, thank you so much. Okay, Bob, let's let you take it away.
All right, let's try this again. Hopefully the computer will not reboot.
That's what happened. Congratulations and welcome back.
All right, everyone see that now?
Yes, we can.
And we're still here. Okay. So I'm gonna talk about all the stuff that's in the BABOK, and I'm gonna add a few things to it, and then Cliff is going to add even more nuggets of brilliance. So Data mining is basically about processing large quantities of data to gain useful insights and to support decision making for an organization. The BABOK describes three different kind of divisions. One is descriptive techniques, and those are describing the data. So that's like plotting everything out or otherwise classifying it so you can see if there are any patterns or trends or clusters or other things going on that jump out at you. Then there are diagnostic techniques that show you a little bit about why certain patterns or trends exist. And then there are predictive techniques that show you something about future outcomes, and they all have their strengths and weaknesses. There are a couple of other terms that the BABOK talks about. One is top down and the other is bottom up searches or exercises. And they're considered top down if the goal is to develop and tune an existing algorithm, and the bottom up to discover patterns. They're said to be unsupervised if algorithms are just run on a fire and forget basis, kind of the way anti-aircraft missiles sometimes work. You just run it and their results are what they are. And they're supervised if you run them and apply feedback and so on in hopes of trying to find something specific. So our friend Richard Frederick about 2 years ago gave a series of presentations or webinars to the Tampa IIBA. And one of the slides that jumped out to me was this one, where they plot analytics maturity versus business value. So if you see from the lower left to the upper right, you've got descriptive, diagnostic, and predictive in here. You've got data quality a little bit lower, and that's really about just making sure your processes work and you can do what you need to and that it's accurate. That has to happen before anything else. Then there is prescriptive algorithms and processing further up the maturity chain, and that tells you something about what you should do. And then even higher up than that is semantic processing, which is really based on far more complex and iterative methods, or integrative, sorry. So there's a lot going on here. We'll revisit that in a minute. Data comes from many different sources. I described the processes in other posts of discovery, which is where you find out what's going on. You find out the nouns and verbs of a process. And then data collection, where you find out the adjectives and adverbs that characterize a process. So when you're talking about data mining, you already have to know the context from having done discovery. And really what data collection is about in this context is really about the operational data for a system and the descriptive data. So all of that happens typically in the conceptual modeling phase of my analytic framework at step 2. But in reality, it comes from all phases, particularly when the thing is running over time and there's a lot of data. You might do a standalone analyses for one-offs like forensic or problem solving or other ad hoc analyses to answer individual questions. But if you want to develop something that's an integrated part of your ongoing process, that really happens as part of requirements design and implementation. So that's where you do the deployment. If you're going to put together a data mining process, the BABOK says you go through a few steps and they parallel the steps in some way, like the steps of my framework. So you start out with the requirements elicitation, and that's where you identify what you're trying to accomplish. And then you prepare the data. And the interesting thing about this is if you have a giant set of data, you cannot use all of it to test or to develop your system. So you have to use some of it to develop the system and the logic of whatever algorithm or algorithms you're using. And then you have to leave another set of data that you can test that algorithm, and still another set to validate it. So you can't just go develop a system or an algorithm or an approach using all your data and turn it loose in the world because a lot could go wrong. So the data analysis phases, that's where you're getting creative and you're tuning things and choosing the best algorithm that meets your needs. Then there are modeling techniques. That's also where you pick the algorithm, the best one. And then deployment is where you actually implement it and build it into your process. So if we have an operating process here in, say, the top row, which is all the white boxes, stuff comes in, we collate and condition it, and then we start doing stuff to it. And then we make a decision of some kind based on the operation of the process or the judgment of a human or some other kind of decision sieve. And then we take alternate actions based on that. And then we do final disposition and exit. Let's say we already have a process that does that. This is notional and abstract. all those processes generate data. All of it can be archived. There can be many more sources. Again, there can be as much volume and as many kinds of data as you can possibly imagine. So now let's look at this 5-step process in the dotted boxes. So we have the requirements down here, and then the preparation, the analysis, then we identify and develop the correct techniques. I know I've used a few of them in my time. We'll get into some of them below. And then you actually deploy it using some kind of a language or engine that performs the calculations based on what you've developed. And then you integrate that into your current system as either a replacement for an existing process or as an additional new process. So that's, if you were going to do this as a one-off, you wouldn't deploy it. You just do the analysis in these 4 steps and get an answer that gave you something actionable as a result, and then you do it. So this is not in the BABOK, this section of stuff explicitly. Let's look at a few ways that data can be mined. There are regression and curve fitting type algorithms, and they allow you to interpolate and extrapolate, both of which are predictive methods, but they can be used for other things. For example, we had standard processes we were supposed to use for the government of Canada's analysis of land border crossing, known as the US government, that I remember. And their process was to take the last 10 years of crossing or traffic counts at every land border crossing and figure out what the best fit of was for a linear regression or a square regression, a second order polynomial regression, whatever had the highest correlation, we'd use that. One thing to look out for is if you have anomalous data, you should be aware of that. So for a 10-year period, the major traffic dips that happened around 9/11 probably skewed the data to make it look like cross-border traffic was going to grow faster than it actually did. And given the kerfuffle we've had the last couple of years, we may have something similar happen now. There are also different kinds of correlations and associations, and they test parallel streams of data that might allow you to detect in affinities, like if customers like product A, they might like B and C. That gets you into the long tail that's interesting. Neural nets and deep learning allow systems to process a lot of related data in dense but coherent streams like sounds and images and things like that. And they sensitize different neurons within the network to pick stuff up algorithmically that humans would not. There's a lot of interesting stuff going on there.
Bob,
There's
is that what Spotify uses?
no idea.
Okay.
I don't, I know certainly Amazon uses, you know, a lot of companies use, if you like A, you might like B and C. Cliff will get into some things Nielsen uses, so we'll come to him in a second. If you remember the chart up above in the far upper left, right-hand corner in the top, the most long-haired and difficult kind of processing is semantic processing, and that associates and tries to integrate data from a wide variety of sources based on commonalities like location, group membership, timing data, behaviors, and so on. And then I spent many years doing simulations of various kinds for operations research, and they're all very data driven and very heavy. If we look at it from another point of view, we might think of a maintenance process. So I tend to use things from my working career. They tend to be mechanical rather than pure IT or paperwork, but they're all data. The same thing applies to every kind of process. I've done enough name, address, phone number, account number, transaction number kind of projects where I know the same techniques are germane to both. So we might examine a large swath of historical data to figure out which parts fail most often, so we know which parts to try to improve and how, or which ones we need to keep more local shelf stock available, so we can do the repairs quickly instead of having to wait for something to be shipped in. We can see, for example, whether we can extend the time between scheduled maintenance events, and if we can get away with that without incurring more failures. We can use data from real-time integrated sensors to try to learn what goes on inside a complex machine to try to sense problems before they happen. That can also be combined with the historical data from many other systems. So there are a lot of ways that you can do this, and I linked to a Wikipedia entry. There's a huge amount to say about data mining, far more than we can cover in 15, 20 minutes here. So just be aware the BABOK gets a fairly brief treatment, and we've covered the major concepts here. Cliff, would you be so good as to add some commentary here?
Sure. And there's so much that's changed about this in just the last 5 to 10 years. The computing power that's available is unbelievable now. I came from almost 20 years at Nielsen. Assuming most people know what Nielsen is. Nielsen Media, Nielsen Research, they do all kinds of stuff. And they kind of cheated. Nielsen, you have to be a Nielsen family. They have a controlled population. They gather all kinds of data on a Nielsen family, for everything from their browsing history to their driving history to their watching TV history down to the minute. So what they do, because they have that controlled environment and data process, they have all the information on everybody at your house, if you're a Nielsen family. So they have ages and just the personal metrics of everybody. And they can associate that with, what are you watching? Did you watch this commercial? Did you later on purchase what was in that commercial? Um, did you see this sign on the road? A lot of people don't know they have an outdoor group, which actually monitors all the billboards and all the signs at every baseball stadium, football stadium, along the roads, and they can actually analyze who's seen it and if that affect a purchase. So that's the golden media. That's what I call cheating, Nielsen, because they have all the metrics on each person. Nowadays, with the computing power that we have at Microsoft, we have Customer Insights, which is a product, and Google has Google Analytics. Um, what those systems allow you to do is you can collect all the data you want from various sources, various tables within your company, outside of your company, point it to a product like this, and it makes connections. So let's say you have a table of all the purchases, I'm going to date myself, from Sears, Kmart, and da da da. And you ever notice if they have just a little bit of unique data on that customer? So you check out at a register at a lot of places. One of the things they ask you for is, what's your phone number? What's your email? And if you give that data, that allows them to later on take all that data. They got another table which might have your email address, your address, your phone number, and they can link that purchase to you and get a total picture of everything you've bought. And you could just smile at all the analytics they can pull. And then, Bob, you were talking about predictive analytics. How many people have done a search, or even worse, we're talking about something that they might have needed or might have wanted, or a product that looked interesting, and all of a sudden the next day you're getting advertisements for those products or emails? Has anyone else had that happen to them? Or
We know they're listening to us.
oh, absolutely. It's kind of like proof. My wife thought I was nuts. It's like, you know what? Just wait. Let's talk about something. And tomorrow, damn sure she'd get an email. It's like, oh, you know what? We have this. Or she was talking about taking a cruise to here, and all of a sudden we're getting Norwegian emails or Carnival emails about, oh, we have cruises and deals. It's just crazy, 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 crazy. But that to me is the kind of analytics that is what customers are doing, what companies are doing with your data that just wasn't available before. This scaling of this kind of data, back in the old days, you had to source this data on local servers. You had to have all these servers set up, and you had to have the power and the processors and everything else. That doesn't exist anymore. Huge, huge data farms that we all have heard and know about. Google, Microsoft has a personal private network, their cloud network, that is bigger than all the other companies combined. A lot of people don't know that. Microsoft's one of the biggest. Google and of course Amazon are right behind. But what that does is that gives you the processing power that's just was never available before. So back in the old days, you get a couple of tables and you'd have to tell it, oh, well, you know what, check and see if emails match from one table to another. now with these new tools and the processing capability, you don't even have to do that. It will literally search all your data sources, millions or billions of rows, and search for connections and make them automatically for you. You used to have to tell. It's like, oh, well, search for an email address here and an email address here, see if you can make a link. And then let's find a customer table with that email address and see if we can find out who it is. A lot of this stuff is being automated now to a scary, scary, scary degree, and unbelievable processing power. I mean, we set up stuff that goes through billions of rows and can do it in minutes and give you all kinds of analysis of just almost anything you want. And we just, Bob, you were talking about predictive analytics on like repairs. We just did a project for BP on their drilling platforms, and also a database on where all their high level repairmen are at. And what they're able to do is predict through past maintenance history when something's going to be serviced. And they can not only send somebody out there with just the basic amount of skills and have them connect visually to a high level engineer, which are far and few between, so that those guys don't have to go out to every drill platform, and they can remotely maintain these platforms that are worth unbelievable amounts of money. If they go down for a day, it could cost, not that we care what oil companies cost right now, but you know, these platforms are just so important to them. And that's just one maintenance structure. You can do it a lot with transportation, keeping your trucks maintained so that they don't break down, which is another very important thing right now. We don't want trucks breaking down while they're trying to do deliveries across the country for various products. It's
Right.
There are just so many examples of how to use this, and the computing power that's available now to almost anybody is just making this field go nuts. That's all. And it's my spiel. I really didn't have a presentation. I was just adding on to what Bob had.
Nice. Yeah, I've had friends that work in various aspects of that, and I've touched on it some myself. So it's a really fascinating field. There are tons of courses. I'll recommend by Super Data Science. I think they changed their name. There's one group that provides a ton of courses on machine learning and so on Udemy. So if you want a quick and dirty intro to the subject, where you can go as deep as you want on some of these tools, all that information is out there.
Yeah, I don't know about you, Bob, but back when we went to, or at least when I went to school, they didn't have a data science department or even a data science degree.
No, they
It is
didn't even
management
have
information systems was
computer
all they had.
science major at Carnegie Mellon when I was there. It was just applied math. So
Yes,
that's how old I am.
yeah, a lot of the early computer degrees were basically math degrees.
Right.
A lot of math. It still is. It's just you let the computer do it.
Yeah, for real.
All right.
Okay. Does anybody have any questions about this topic? Can anybody tell me how you've used this in your industry or your past jobs?
I can say something.
Tell us,
Oh.
Sylvia.
Bob always stretches my brain because it's in a whole different direction. I just love that. It's hard to listen to, but I have to force myself sometimes because he goes way out in a whole different field that I'm used to, but it's good. It's good for me. And So I'm thinking more of web development when I was doing PHP coding and using the databases, the SQL databases, and how pulling the data and how we gathered that. But it wasn't as elaborate as what Cliff was talking about. But now doing the margin analysis stuff I'm doing with the SAP databases, and we're compiling the data out of the database and analyzing it to fix things, millions of dollars worth of stuff. But you know, Excel's the cheapest version of that. But I went on a job interview the other day and they were trying to milk me for information, so I referenced your Microsoft Dynamics program, which is super expensive, I'm sure. So I knew they were just trying to get information out of me because of my extensive history and weren't going to hire me. So I gave them that. But, you know, just using Excel is a simple form of mining data. You know, that's a very basic thing. And most companies use that. It's inexpensive and it's surprising. A lot of people don't even know what Excel is capable of. Like, you can do so much with it. It's unbelievable. But
it can handle files up to 2 gigabytes, and we used to generate, and that was 10 years ago. So we used to generate data files out of our simulations that were so big Excel couldn't even handle them. So we ended up having to write our own parsers that would parse the output and generate reports for it.
yeah.
If you could just learn filtering and pivot tables, you have a huge advantage.
Yeah.
Absolutely, I agree. I'm going to LinkedIn Learning courses and brushing up on my Microsoft Excel, because I was trying to do a business analyst program and they would tell me, you gotta know Excel, you gotta know Excel, you gotta go. There's like, if you go on LinkedIn Learning, I highly recommend LinkedIn Learning. Is the quality is top notch. The experts there are experts, and you get a lot of practice problems. There's a lot of exercises you can do, and like they have different, like they have Excel for beginners, they have for intermediates, like medium. You can master Microsoft Excel, so I highly recommend. And they told me one of the training programmers, she was like, you got to know Excel if you want to get into BA. And I was like, okay. So I'm brushing up on my Excel.
Mhm.
And again, showing our age is, you know, back in the old days of Excel, it was a 16-bit program, so it would handle like 65,000 rows, which
Yep.
sounds like a lot.
You get
Now now that it's a 32-bit program, even with Excel, it's just over 1 million rows. So I have done some data analysis on the smaller projects, which have, you know, 1 million records per entity kind of thing. And you can do that in Excel. It's a little slow. It depends on what kind of computer you're running it on. But you can go up to about 1 million records. It is pretty impressive what you can do with Excel. What we do with SQL and customer analytics and customer insight products. Yeah, those are millions and billions size tables. They're just absolutely huge. And you can analyze them in minutes. That's what scaled computing is all about. You see the server farms and what you're paying for at a Microsoft or an Amazon or a Google when you get those services is the ability to go from one processor to 100 processors working on your query in a split second. It can just scale up and scale down that quick. And that's the kind of power that just wasn't available just a few years ago. I mean, it just wasn't available.
The other thing that's interesting about artificial intelligence and machine learning is it's not mostly as mysterious as people make it out to be. Now, a full system like IBM's Deep Blue, yeah, that's deep stuff. But a lot of the algorithms shouldn't be called anything like even machine learning or artificial intelligence. I've been on the periphery of AI research since the early 80s. I actually did 2 semesters of an independent study project building an AI natural language system to teach engineering students how to set up and solve certain kinds of problems. And you know, I read about artificial intelligence and how they were approaching it at that time, and I paid attention to it in all the years since. And you know, it's a very, very fiendishly difficult problem. We don't actually know how our own intelligence works. So there's a lot going on in this, but there the things that we can do with the advent of all the computing power, high performance computing and clustering and parallel processing and so on that Cliff's talking about is where the power comes from. We don't even want to think about what will happen if we ever do come up with something that's truly artificially intelligent.
Terminator. No.
Unfortunately, you might be right.
Paloma has has her hand up here nicely.
Oh,
What's
yes,
up?
yes, please.
Hi, thanks. So I guess I'm wondering if anybody here has any experience or just knowledge of what's to come, in particular with maybe healthcare predictive analytics. For example, you know, real-time lab values and vital signs that like an aide or a lower trained provider can, you know, get the heads up and then maybe connect to a telehealth doctor as an intervention based on this big data analytics. Like, do you know of anything like that going on?
I can think of a couple things. One, everyone has something like this, or more people do. And they have fault analysis on here. They have irregular heartbeat analysis. They have asymmetric gait analysis. So when they can combine like changes in your heart rate against what is known about bad health outcomes, and you can look at anomalies that might be detectable leading up to that in a large population of people, that's one thing. There's a huge amount that's going to happen that gets down to the level of individual genetic codes, where they'll really be able to target drugs toward people with highly individualized conditions. And there's a ton going on right now. Like right now, the process of developing and testing drugs, it looks very scientific, but it's actually quite Cro-Magnon. You just do stuff and try a lot out on a certain number of people, and you hope they don't die. And, you know, they've killed a bunch of people in various trials for various reasons. It'll make you mad if you know the degree to which they do that kind of thing. But that whole area, there's so much farther to go, and that's where it's going. And then, of course, there's issues of what the government and the NSA are doing in medical privacy and so on. So there's a lot of considerations to think about.
Where would you point someone that was interested in kind of those policy topics as this tech develops? I mean, is it like think tanks, like the RAND Corporation, or You know, like where would you point somebody?
Oh, I'd stay away from mine personally. I mean, I know what sources I read, they're not mainstream. I probably wouldn't be very popular if I shared the actual sources, but there's a lot of material on this stuff. If you look, since I don't care if I formally get hired any place, I can't tell you. If you really want to know, we'll do that as a sidebar. You can contact me at your convenience.
I sure will. Thank you, Bob.
And like I was mentioning with Microsoft Customer Insights, they actually have, they're gearing their systems towards brands of they do have healthcare. They do have different lanes. I'm having a brain fart on what they call them, but basically different verticals, and they derive systems based on that. So you have a sales, or you have finance, and those verticals for like a healthcare or something along those lines. I actually helped Microsoft develop their test data for a lot of those verticals, so that when they demo systems, their systems would have data in it, so that they could generate reports and those kinds of things for people just on the fly. It's all dummy data, but you can't demo a system without something in it.
Yeah.
Because it just, but it's fake data that makes a system look good, so that when you present it, it at least has something in it. But yeah, they're all going that way. I'm skewed towards Microsoft because that's where I work, but Amazon has that, and so does Google. All three of those platforms are just absolutely huge on this.
Okay, we've talked about Excel and we've talked about some other things that people can learn. I'd like to point y'all also to Power BI. Power BI is able to pull from about 40 different applications easily. I mean, you can say, go look at this over Excel and then pull this over here from SQL Server, and you can pull them together in Power BI. Power BI allows you to take information, pull it all in, and then show 15 different views of it. So that, your system owner wants to see one view, and then the data owner wants to see a different view, and it can be refreshed in almost real time because of the pulls that it's able to do. I don't know if it's REST APIs or what, but Power BI is a great translator between systems. Cliff, you said you have used or know of people using Power BI to.
Oh, well, that's a Microsoft product. So yeah, and usually Power BI, it depends on how you set it up, but most of the time it stages it. So you set up a connector, like you said, and they do have tons of connectors that connect with all different kinds of data sources. And a lot of times you can set it up to refresh every 15 minutes, or if it's a huge data set, maybe 4 or 5 times a day, which is pretty damn close to real time. Some of the reports that you can get, that's been a game changer on a lot of things. Is a lot of companies don't know what's actually going on, and now the fact that they can get today or last hour's information real time in a report that they understand, because Power BI is very graphical. Like Bob said, I love Bob's analogy. Picture's worth 1,000 words. And God, if you can animate it, that's even, it's even better. It seems like it clicks for a lot of people rather than just looking at a sheet of data. But that's all stuff, yeah, you can do in Power BI. It's just, you're right. It's an awesome tool. We use that one a lot too.
One of the ways that we've used it most successfully for executives or to show current status is there's a thing called a dashboard, and you can literally say, this box means this system, and it's red, yellow, or green. I mean, it just shows you at a glance, you can see all the statuses and then click on it and drill down into it if you need to. So Power BI is a thing that I would suggest you look into learning more about. I mean, Excel is phenomenal. Power BI is kind of cool.
It's Excel on steroids.
Tableau
Yeah.
is similar, and I program my own tools to do some of these same things.
I have
So
a
make
project
my own graphs,
for Bob
real-time school
with Amazon.
graphs.
Sorry, I thought you were finished. With Amazon. Go ahead. With Amazon, there's a, because your site's in WordPress, there's an app called Amazon Polly, because I made an Alexa app one time using Amazon Polly. It's a, you add it into your WordPress site, but you're grounded in the Amazon business part where you put in the programming there, but you also connect it to Spotify, Apple, and the other one. Can't think of Pandora, maybe. I can't think of what the other one was.
That's cool.
Pandora, iHeart, yeah, there's.
I'm
lots of
surprised
them.
that Bob doesn't have a channel already with his Amazon Polly.
You know what? He might. You just don't know everything Bob's
No,
into.
you would see it on there. I
No,
didn't see
no,
it on
no. He doesn't put everything out there.
there.
Okay, guys, we're about 10 minutes past our
Yeah.
deadline. If anybody has any questions or concerns, contact us or contact me directly and I'll be glad to help you. Next week, we are going to talk about, let me pull up my little handy dandy here. Next week, we're going to go through business rules analysis. We are going to go through reviews by Bob and sequence diagrams by Tish. So we got those to do. If we have, I think that's it. So I think that'll fill up our next week. Once again, if anyone has any questions or concerns or needs any help, contact me. Thank you.
Hey, Tia, can you
Alright,
stay
guys.
on the call afterwards? I would like to chat for like a
Oh.
couple minutes, if you don't mind.
Actually, we can't because we got to close the call, but why don't you give me a call? I'll send you my phone number.
I'll give you a call. Yeah, I can give you a call. Like right now, after the call.
Yes.
Okay, please. Thank you. Appreciate it. Thank you so
All
much.
right, guys, I'll talk to you later.
Okay, bye.